Welcome everyone. I'm excited to kick off today's presentation on data handling. This is our first slide, serving as the cover. We'll explore key concepts, best practices, and strategies around data management. Over the next few slides, I'll guide you through what you need to know to handle data effectively and securely. So let's get started. Let's take a quick look at what we'll be covering in this presentation. On this slide, you see the contents listed out. First, we'll start with the topics to be covered, beginning with how we organize data. This is fundamental because understanding how to gather and structure information is the first step in any data analysis. Next, we'll explore ways to organize data using tally marks, which is a simple and effective method to count and record data quickly. Moving on, we'll discuss how to present this data visually through pictographs, including how to draw them and interpret what they show us. Following that, we'll look at bar graphs, another powerful way to display data visually. We'll understand the two main types of bar graphs and learn how to interpret them to extract meaningful insights. Throughout the presentation, you'll see examples that illustrate these concepts in real-life scenarios, making the ideas more tangible. Towards the end, there's a self-assessment test to help you check your understanding. And finally, we'll wrap up with a thank you. Overall, this presentation is designed to build your skills in organizing and interpreting data, which are essential for making informed decisions. So, let's dive into each of these topics step by step. Let's talk about the topics we will cover today. First, we'll explore what data really is. Think of data as a collection of numbers that help us understand different things around us. For example, imagine recording the attendance of students in a class every day. Those numbers tell us who's present and who's absent. Or consider the marks students get after each test or exam. Those scores are also data, giving us a snapshot of performance. We might also look at the ages of all students in your class, another form of data that shows us the age range. Another interesting example is the choice of sweets or fruits that students in 6th grade prefer. The size of their shoes or the marks they score in a test are all data points that can tell us something useful. By collecting this kind of data, we can analyze patterns, make decisions, and better understand the world around us. Throughout this presentation, we'll see how data is everywhere and why it's so important to learn how to work with it effectively. Let's talk about the importance of data organization. When we want to find specific information quickly from a set of data, the first step is to organize or arrange that data properly. This makes our job much easier and saves us time. Now, there are several ways to organize data. One common method is to sort it in ascending or descending order, depending on what fits our needs. This helps us see patterns or identify highest and lowest values easily. Another useful way is by using pictographs, which are visual representations that make data more understandable at a glance. Tally marks are also a simple but effective method, especially when counting frequencies or occurrences. Finally, bar graphs are great for comparing different groups or categories visually. All these methods are essential tools in data organization, and they connect directly to our overall goal, making data clearer and more accessible so we can make informed decisions quickly. Now, let's look at how we can organize data efficiently using tally marks. Tally marks are a simple and effective way to represent numbers in groups of 5, making it easier to count and visualize data at a glance. Here, you can see the basic representation. For numbers 1 through 4, we use vertical lines, 1, 2, 3, and 4. When we reach 5, instead of 5 individual lines, we draw a diagonal across the 4 vertical lines, which stands for 5. Notice that 5 plus 1, which is 6, is represented by the 5-line group plus an additional vertical line. Similarly, 7 is the 5-line group with 2 more lines, and so on. This pattern continues, making it quick to count large quantities by grouping in 5s. It's also worth noting that both III and III are acceptable ways to represent 5. Either way works, and the key is consistency. Using tally marks simplifies data organization, especially when you're working with large data sets. and it connects directly to the overall theme of making data easier to understand and interpret. Now let's look at this table showing the number of students choosing different sports. We have 6 sports listed here: badminton, cricket, football, hockey, tennis, and volleyball. For each sport, the table shows the number of students who selected it, which we call the frequency. For example, 5 students chose badminton, 10 chose cricket, and so on. You can see the tally marks next to each number. These help us quickly count the frequency. 4 tally marks represent 4 students, and more tally marks are added in groups of 5 for easy counting. The key point here is understanding what frequency means. It's simply the number of times a particular value or choice appears in our data set. So, in this case, the frequency tells us how many students picked each sport. This kind of table helps us organize data clearly, making it easier to analyze and interpret. It's a fundamental step in creating what's called a frequency distribution table, which is useful in understanding the overall pattern or trend in our data. In the context of our overall presentation, this table is a practical example of how we can visually and efficiently represent data collected from a group, making it easier to draw meaningful conclusions. Let's take a look at this table, which shows the distribution of marks obtained by students, along with their tally marks. As you can see, for each mark, we have the number of students who scored that mark and the corresponding tally marks. For example, 2 students scored a 1, represented by 2 tally marks, and 3 students scored a 2, shown with 3 tally marks. We observe that the highest number of students, 7, scored either a 4 or a 6, indicated by 4 tally marks for each. This table helps us quickly understand how the scores are spread out among the students, giving us a visual sense of the frequency of each score. Now, moving to the second part of this slide, we have a specific example involving the marks obtained by 40 students in a mathematics test. The marks listed are a mix of numbers from 1 to 9, and our goal is to organize these into a frequency distribution table using tally marks. Once we've arranged the data, we can answer some questions. First, how many students scored 7 or higher? By summing the students who scored 7, 8, or 9, we find there are 12 students in total. Second, how many students scored below 4? Counting those with marks 1, 2, or 3, we see that 8 students obtained marks below 4. This process of organizing data into a frequency table helps us analyze and interpret the results more effectively, giving us clear insights into the performance of the students. Now, let's talk about pictographs. A pictograph is a way of representing data using pictures or objects instead of just numbers. Instead of seeing a long list of figures, you get a visual representation that's much easier to understand at a glance. The key benefit here is that pictures make the data more relatable and simple to interpret. When you see the pictures, you can quickly answer questions about the data without needing to do any complex calculations. This makes pictographs a very effective tool, especially when you want to communicate information clearly and engagingly. Remember, the main idea is that pictures can often tell the story more intuitively than numbers alone, which ties into our overall goal of making data accessible and understandable for everyone. Let's take a closer look at how we interpret a pictograph. The main idea is that we need to understand the pictures and extract the information they represent. For example, in this story, Peter enjoys picking oranges, squeezing them into fresh juice, and sharing with his friends. The pictograph shows how many oranges he picked on different days. Now, to interpret this, we look at the pictures and count how many oranges each symbol or picture represents. The key questions help us practice this. For instance, how many oranges did Peter pick on Wednesday? We look at the picture for Wednesday and count the symbols. Another question asks on which day Peter picked twice as many oranges as he did on Monday. So, we compare the pictures for Monday and the other days to find the right match. The third question is about how many more oranges he picked on Friday than on Saturday. Here, we compare the number of symbols for those 2 days to find the difference. And finally, we're asked to identify the day he picked 45 oranges. We look for the picture that corresponds to 45 oranges. So, understanding a pictograph is about carefully analyzing the pictures, counting the symbols, and comparing the data to answer the questions. It's a visual way to quickly grasp information that might be more complicated if we only looked at numbers. Let's review the answers to the questions on this slide. For the first question, the answer is 90 oranges. This tells us the quantity involved in that particular problem. Moving on to the third question, the answer is Friday, which indicates the specific day related to the scenario. The second question's answer is 75 oranges, showing a different quantity that we need to remember. Finally, the answer to the fourth question is Saturday, the day associated with that part of the problem. These answers are key because they help us understand the different quantities and days involved, which ties into the overall theme of solving problems step by step. It's important to see how each answer connects to the questions and the context of the problem we're working through. All right, let's look at this second example. Here, we have a pictograph that represents the number of students present in class on each working day of the week. Remember, each symbol in the pictograph stands for 5 children. This visual makes it easier to compare the numbers quickly. Now, the first question asks, how many children were present on Monday? To find this, we just need to count the number of symbols for Monday and then multiply by 5. The second question is, on which day of the week were the maximum number of children present? Here, we compare the symbols across all days to see which day has the most. Similarly, the third question asks, on which day were the least children present? So, we look for the day with the fewest symbols. The fourth question is about identifying days where the same number of children were present. So, we look for days with an equal number of symbols. Finally, the fifth question asks, how many more children were present on Thursday than Wednesday? For this, we count the symbols for both days, multiply each by 5, and then find the difference. These questions help us analyze the data visually and understand patterns in student attendance throughout the week. Remember, pictographs are a great way to make data intuitive and easy to interpret at a glance. Let's talk about drawing a pictograph. In a pictograph, we use pictures or symbols to represent data. The key here is that these symbols should be carefully chosen. They need to be clear, concise, and interesting. When selecting a symbol, it should represent a general concept, like a man, woman, child, or a bus, rather than an individual person or specific name. This helps keep the data easy to understand and relatable. Another important point is the key. The key explains what each symbol stands for, so anyone looking at the pictograph can interpret it easily. For example, a key might say that one symbol equals 10 men or 10 fruits. This way, the symbols give us a quick visual sense of the data without cluttering the chart. Remember, a well-designed key makes your pictograph accessible and straightforward for everyone. It's all about making data visual and easy to interpret at a glance, which is a key part of effective data presentation overall. Now, let's look at the data from these 5 villages. We have the number of animals in each village listed here. Village A has 80 animals, Village B has 120, Village C has 95, Village D has 40, and Village E has 60. To better understand this, we'll create a pictograph. Remember, one symbol will represent 10 animals. So, for Village E, which has 60 animals, we would need 6 symbols. This visual representation helps us quickly grasp the differences between the villages. For example, from the pictograph, it's clear that Village B has the most animals, since it has 120, which would be 12 symbols. Now let's answer some questions. First, how many symbols represent animals in Village E? Well, since each symbol equals 10 animals, and Village E has 60 animals, that makes 6 symbols. Next, which village has the maximum number of animals? That would be Village B, with 120 animals, or 12 symbols. And finally, which village has more animals, Village A or Village C? Village C has 95 animals, which is more than Village A's 80. So Village C comes out on top there. This exercise not only helps us visualize data more clearly, but also reinforces the importance of pictographs in comparing quantities efficiently. So on this slide, we have a simple table that shows the number of animals in different villages, with each village having a total of 10 animals. The villages are labeled A, B, C, D, and E. Now, looking at the answers, the first one indicates that the most common response is 6. This suggests that, in many cases, 6 animals are associated with a particular village or characteristic we're analyzing. Next, the answer points to village B as the most relevant or frequently identified village. And similarly, village C is also highlighted as significant. What's important here is understanding how these answers relate to the data. They help us see patterns, like which villages tend to have certain numbers of animals or how responses cluster around specific villages. This ties into our overall theme of analyzing distribution and identifying key areas of interest or concern within these villages. Recognizing these patterns allows us to focus our attention on specific villages, like B and C, which seem to stand out in this context. Now, let's take a closer look at the bar graph, which is also called a bar chart. Essentially, it's a visual way to display data using bars of different heights. These bars can be arranged either vertically or horizontally, depending on what best suits the information we're trying to communicate. The key point here is that the length or height of each bar represents a specific value, making it easy to compare different data points at a glance. As we move forward in this presentation, you'll see how effective bar graphs can be for illustrating trends, differences, or relationships within your data. This visual approach helps make complex information more accessible and engaging for your audience. Let's take a closer look at how to interpret a bar graph. When we analyze a bar graph, our goal is to understand the information it presents by carefully collecting and examining the data shown. Now, look at the given bar graph, which displays the number of shirts sold in a shop from Monday to Saturday. First, we want to identify what kind of information the graph provides. It shows us the sales figures for each day, allowing us to compare sales across the week. Next, notice the scale on the horizontal line, which represents the number of shirts sold. This scale is crucial because it helps us determine the actual quantities from the height of each bar. Usually, the scale will be marked in consistent units, like 10, 20, 30 shirts, and so on. Now, let's find out on which day the shop sold the maximum number of shirts. Look at the tallest bar. That will tell us the busiest day. From the graph, we can see that the maximum sales occurred on, say, Saturday, with, for example, 50 shirts sold. Finally, we need to identify the day with the minimum sales. That would be the shortest bar. Suppose that was Monday, with just 10 shirts sold. Recognizing these extremes helps us understand sales patterns and make better decisions. So, by carefully observing the heights of the bars and understanding the scale, we can interpret the data effectively. This process is central to analyzing any bar graph accurately and connecting it to the larger picture of sales trends or other data insights. All right, let's take a closer look at this bar graph. It shows us the number of shirts sold on each day from Monday to Saturday. The x-axis uses a scale where 1 unit equals 5 shirts, making it easier to compare the sales across days. Notice that Saturday has the longest bar, which means the highest number of shirts was sold that day. Specifically, since each unit is 5 shirts, and the bar reaches 60 units, we can calculate the total shirts sold on Saturday by multiplying 60 by 5, giving us 300 shirts. Now, looking at Tuesday, the bar reaches 10 units, so multiplying 10 by 5 gives us 50 shirts sold. This visual helps us quickly identify the busiest days and understand sales patterns over the week. Let's take a look at this second example. We've got a bar graph here, and I want you to follow along as I point out some key details. First, the question asks us to identify the second most popular subject. So, when you look at the bars, notice which one is the second tallest. That shows us which subject is the runner-up in popularity among students. Next, we want to find out which subject is the favorite for 50 students. Usually, the bar representing that subject will reach the mark corresponding to 50 on the scale. Pay close attention to the height of each bar to answer this accurately. The third question asks us to identify subjects with the same number of votes. So, compare the heights of the bars carefully. If 2 bars are the same height, then those subjects received an equal number of votes. Now, looking at the comparison between science and ELA, which one is less popular? Think about which bar is shorter. The shorter bar indicates the subject with fewer votes or less popularity among students. Finally, the last question asks about the unit of scale used here. Usually, for bar graphs like this, the scale might be in numbers like 10, 20, 30, etc., or sometimes in percentages. Recognizing this helps us understand the actual number of votes each subject received. Connecting all these points to the overall theme, understanding how to read and interpret bar graphs is essential for analyzing data effectively. It helps us make sense of student preferences and patterns in a clear, visual way. Let's walk through the steps involved in drawing a bar graph. First, on your graph paper, draw 2 lines that are perpendicular to each other, intersecting at a point called O. This point is your origin, where your axes meet. Next, along the horizontal line, which we call the x-axis, decide on a uniform width for your bars and also maintain equal gaps between them. Write the names of the data items you want to represent next to each bar. Then, choose an appropriate scale to determine the height of each bar based on the data values you have. This is crucial because selecting the right scale ensures your graph accurately reflects the data without being misleading. After that, along the vertical line, known as the y-axis, select a suitable scale to help you determine how tall each bar should be for the given values. Finally, use these scales to measure and draw the bars to the correct heights. Remember, the key here is consistency in your scaling and spacing, which makes your bar graph clear and easy to interpret. This process is fundamental in visually representing data for better understanding and comparison. Now let's take a closer look at the parts of a bar graph. First, we have the y-axis, which represents the number of students. This tells us how many students fall into each category. Next, we see the use of different colors. These colors help us distinguish between different data categories easily. The scale is also important. Here, each unit on the y-axis equals 1 student. This makes it straightforward to interpret the data at a glance. Lastly, we have the categories of the data, which are labeled to tell us what each bar or group of bars is about. Understanding these parts helps us read bar graphs accurately and interpret the information they present, which is key when analyzing data in any context. Now let's take a closer look at the 2 main types of bar graphs. First, we have the vertical bar graph, which is probably the most common. In this type, the bars are drawn vertically, with the height representing the value. It's great for comparing different categories side by side and makes it easy to see which categories are larger or smaller at a glance. The second type is the horizontal bar graph. Here, the bars run horizontally. This design is especially useful when category names are long or when you have many categories to display. It allows for easier reading and comparison because the labels are aligned nicely along the y-axis. Both types serve the same purpose of visualizing data clearly, but choosing between them depends on what you're trying to emphasize and the nature of your data. Remember, selecting the right type of bar graph helps communicate your message more effectively and keeps your audience engaged. All right, let's take a closer look at this data. Here we have a table showing the number of animals in 5 different villages. Labeled A through E. Village A has 80 animals, B has 120, C has 95, D has 40, and E has 60. The goal here is to construct a bar graph that visually represents this information, making it easier to compare the villages at a glance. When creating the bar graph, you'd want each village on the horizontal axis and the number of animals on the vertical axis. The height of each bar corresponds to the number of animals in each village. Notice how Village B stands out with the highest number of animals at 120, while Village D has the lowest at just 40. This visual comparison can help us quickly identify which villages have larger or smaller animal populations, which is useful for resource planning or understanding regional differences. Connecting this to our overall theme, visual tools like bar graphs are powerful because they simplify complex data, making patterns and differences instantly recognizable. So, when you construct your bar graph, keep these key points in mind. Clear labels, consistent scale, and accurate representation to communicate your data effectively. All right, let's take a closer look at this solution. On the y-axis here, we've set 1 unit length to represent 20 animals. This helps us visualize the data more clearly, especially when dealing with larger numbers. Moving along the x-axis, we have different villages, which are the key points of comparison in this analysis. What this setup allows us to do is quickly see how the animal populations vary across these villages. The height of each bar or point on this graph will tell us the number of animals in each village, scaled to this 20 animals per unit measure. By using this visual approach, we can easily identify patterns or outliers, like which villages have higher or lower animal populations, and this insight is crucial for informing our strategies moving forward. Essentially, this graph simplifies a complex dataset into an easy-to-understand visual, making it clear where our focus should be. Now, let's take a closer look at this table showing the populations of 4 major Indian cities: Mumbai, Kolkata, Delhi, and Chennai. The figures are given in lakhs, which is a common way to measure population in India. Notice that Delhi has the highest population here, with 150 lakhs, followed by Kolkata with 130 lakhs, Mumbai with 120 lakhs, and Chennai with 80 lakhs. This kind of data is perfect for visual representation through a bar graph, which makes it easier to compare the populations at a glance. The instructions specify that the y-axis represents population in units, where each unit equals 20 lakhs. So, when you draw the bar graph, each bar's height should correspond to the population of each city scaled appropriately according to this unit. The x-axis will list the cities: Mumbai, Kolkata, Delhi, and Chennai, so viewers can quickly see which city has the largest or smallest population. By constructing this bar graph, we transform raw data into a visual form that highlights differences and helps us analyze urban population distribution more effectively. Connecting this to our overall theme, visual tools like bar graphs are essential in presenting demographic data clearly and convincingly. They allow us to grasp large amounts of information quickly and can reveal patterns or trends that might not be immediately obvious from just looking at numbers. Let's take a moment to look at the population data for these cities. The question is, which city has the maximum population? The answer is Delhi. As you can see, Delhi stands out as the most populous city among the ones we're examining. Now, on the flip side, which city has the least population? That would be Chennai. This comparison highlights the diversity in city sizes and populations across the region. Understanding these differences is key to appreciating the unique challenges and opportunities each city faces as part of our overall discussion on urban development. All right, let's go through this self-assessment together. First, we have a question about tally marks and representing the number 8. When you're counting with tally marks, remember that groups of 5 are typically marked with 4 vertical lines and a 5th line across them to make it easier to count. So, which of these options best shows 8? Think about how you'd write that using tally marks. Next, we look at the question about the eggs. If 0 represents 5 eggs, then what does 4 represent? This is a bit of a trick question, but the key is understanding the relationship between the symbol and the quantity. It's a simple proportional idea, so if 0 is 5 eggs, then 4 would logically be 20 eggs. Moving on to the graph question, what is the vertical line called? This is fundamental in understanding graphs. The vertical line is called the y-axis, which usually represents the dependent variable or the quantity we're measuring. The horizontal line, on the other hand, is the x-axis. Now let's interpret the tally mark shown. To find the total, we just count the groups of 5 plus the remaining marks. So 4 groups of 5 give us 20, and the remaining 3 add up to 23. But wait, let's double-check the options. It's important to get this right. Lastly, we have a question about representing a large number of balloons with symbols. If each equals 5 balloons, then to reach 60 balloons, how many symbols do we need? Just think about how many groups of 5 fit into 60. That's 12. So, drawing 12 symbols would represent 60 balloons accurately. Remember, these kinds of questions test your understanding of basic data interpretation and counting methods, which are fundamental skills in many areas. Keep practicing, and you'll get more comfortable with these concepts. Let's go through some key concepts about data representation and interpretation. First, A is essentially a collection of numbers gathered together to give us some meaningful information. Think of it as the raw material we analyze to understand patterns or trends. Next, A is a visual way to represent data using pictures of objects. For example, if we want to show quantities, we might use icons or images to make the data more understandable and engaging. Now, on a scale where 1 unit length equals 10 crore, if we have a bar of length 6 units, that bar will represent crore. Similarly, if another bar measures units, it will represent 75 crore. These scales help us translate physical measurements into real data values clearly. Moving on, when we arrange data in a tabular form, we use marks. These are the columns and rows that organize our information systematically. This makes it easier to read and interpret data quickly. Lastly, in a bar graph, can be drawn either horizontally or vertically. This flexibility allows us to choose the orientation that best suits the data we're displaying, making the graph more effective and easier to understand. By understanding these elements, we get better at analyzing and presenting data in ways that are both clear and meaningful. Let's take a closer look at this table. Here, we're representing data about shirt sizes among students using tally marks. The goal is to visualize how many students fall into each size category. Notice that for size 30, there are no tally marks, which means no students chose that size. For size 32, we see 4 tally marks, indicating 4 students. Similarly, size 34 has no tallies, so no students in that size category. When we look at size 36, we see 5 tally marks. This actually shows us a total of 5 students, but in this particular table, it appears that the tally marks are grouped in a way that helps us count quickly. Size 38 has 4 tally marks, representing 4 students, and size 40 has a single tally mark, meaning just 1 student. This visual method using tally marks is very effective for quick data interpretation, especially when dealing with larger groups. It simplifies counting and makes it easier to see which sizes are more common. Now, connecting this to our overall theme, understanding data representation like this helps us analyze and interpret information efficiently. Whether we're looking at grades or shirt sizes, clear data visualization is key to making informed decisions. Let's take a look at the table showing the number of students present on each day of the week. You can see that Monday had 24 students, Tuesday had 26, Wednesday 28, Thursday 30, Friday 29, and Saturday 22. This data helps us understand the attendance pattern throughout the week. Notice that Thursday had the highest attendance with 30 students, while Saturday had the lowest with 22. Recognizing these patterns can be useful for planning activities and understanding student engagement. Now, moving on to the long answer questions about shoe sizes. The first question asks which shoe size is worn by the maximum number of students. If you look at the bar graph, you'll see that the tallest bar corresponds to a particular shoe size, indicating the most popular size among students. Next, we are asked to find the total number of students whose shoe sizes have been collected. To do this, we need to add up the number of students across all the shoe sizes shown in the graph. This gives us an overall picture of the distribution of shoe sizes in the class. Furthermore, there's a question about the number of students wearing shoe size 6. By examining the graph, we can identify the specific number associated with size 6, which helps us understand the popularity of that particular size. We also need to determine which shoe size is worn by the fewest students. Again, by looking at the graph, the smallest bar indicates the least common shoe size among the students, highlighting the least popular size. Finally, the last part of the slide shows data about the number of students in a class of 30 over a week. This data is represented through a pictograph. Visual representations like this make it easier to quickly grasp the attendance patterns across different days. Overall, these data points, whether about weekly attendance, shoe sizes, or visual representations, are all about understanding patterns and making informed observations. They help us see how data can tell us stories about student habits and preferences, which is an essential skill in analyzing information effectively. Let's take a closer look at this pictograph that shows the number of scouts in different classes. Each smiley face represents 10 scouts, which makes it easy to visualize and compare the numbers across classes. First, identifying the class with the maximum number of scouts is straightforward. We can see that class VIII has 6 smiley faces, meaning it has 60 scouts, which is the highest among all the classes. Next, let's consider the question about class. Counting the smiley faces, class VI has 4 smiley faces, so it has 40 scouts. Now for the question about class X, which has only 1 smiley face, meaning 10 scouts. The question asks which class has exactly 4 times the number of scouts as class X, since 4 times 10 is 40. The answer is class VI, which also has 40 scouts. Finally, when we look at the total number of scouts from classes VI to X, we add up all the smiley faces. 4 in class VI, 2 in class VII, 6 in class VIII, 3 in class IX, and 1 in class X. Putting those together, the total comes to 4 plus 2 plus 6 plus 3 plus 1, which equals 16 smiley faces. Since each face is 10 scouts, that gives us 160 scouts in total across these classes. So this pictograph not only helps us quickly grasp the distribution of scouts, but also reinforces the importance of visual representation in understanding data. It connects to our overall theme of analyzing and interpreting data effectively. Let's take a closer look at this table, showing the number of bicycles manufactured from 1998 to 2002. As you can see, the data varies each year, which gives us a good opportunity to visualize these numbers using a bar graph. Remember, when creating the graph, you can choose a scale that best fits the data to clearly show the differences between the years. Now, focusing on the key points. Which year had the highest production? That would be 2002, with 1,200 bicycles manufactured. It indicates a peak in production, possibly reflecting increased demand or expanded manufacturing capacity. On the other hand, the year with the lowest production was 1999, with only 600 bicycles. This dip could have been due to various factors like supply chain issues or market conditions. Connecting this to our overall theme, understanding these fluctuations helps us grasp how production levels impact business strategies and market response. By analyzing such data, we can make informed decisions to optimize future manufacturing processes.